Hello students, welcome to Diksha Karnataka YouTube channel. In this video, I'm going to discuss COMEDK 2023 previous year paper. Okay, question number 1 to 30. So, if you haven't downloaded the paper is given in the description box with the solution. Okay, so please join the WhatsApp channel using the link. In there, you will get the question paper and solution. Okay, yeah. So, the first question. The mean energy of the molecule for diatomic gas is, okay, so here mean energy per molecule for diatomic gas, right? So mean energy per molecule, right? So which is equal to F divided by 2 into K into T, okay, or Kb into T. Kb is Boltzmann constant, T is absolute temperature. What is F? F is degree of freedom for diatomic gas. Okay, for diatomic gas, degree of freedom is 5, 3 translational, 2 vibrational, right? So mean energy will be 5 divided by 2 into Kb into T. So the correct option is C. Okay, yeah. Next one, question number 2. The phase difference between the displacement and velocity of a particle in simple harmonic motion. Okay, what is the general equation for the displacement? X equal to, in simple harmonic motion, the general equation for displacement x equal to here A, x equal to A into sine of omega t, right? So now differentiate x with respect to t. You will get v, right? So v equal to dx by dt equal to a omega cos omega t, right? A omega cos omega t. So now I can rewrite this equation as v equal to a omega sine omega t plus pi by 2 right? So here sine of pi by 2 plus theta is cos theta, right? So sine of omega t plus pi by 2, right? It is equal to cos of omega t, right? So the phase difference between displacement and velocity is pi by 2 radian. So the correct option is D. Okay. Third question. The mass density of a nucleus varies with mass number as. Okay, mass density of the nucleus does not depend on the mass number, right? So it is constant. So option A is the correct answer. Angstrom, right? Yeah. Question number 4. A capacitor of capacity 2 microfarad is charged up to a potential 14 volt. Okay, so this is C1 and here this is V1. Okay, and then connected in parallel to an uncharged capacitor of capacity 5 microfarad, the final potential difference across the capacitor will be. Okay, so the capacitor is charged by a potential 14 volt. What is the capacitance of that capacitor? 2 microfarad, right? So now it is charged, right? So now this charged 2 microfarad capacitor connected with uncharged capacitor of capacitance 5 microfarad. So what is the charge on 2 microfarad capacitor? 2 into 14, 28 microcoulomb, right? So 28 microcoulomb initial charge on this capacitor. So now what happens if you connect the uncharged capacitor to a charged capacitor parallelly? What happens? The charge will start to flow, right? The charge will start to flow to the other capacitor until their potential becomes equal, right? So now what is the common potential? The common potential V is equal to, we have the formula, right? C1 V1 plus C2 V2 divided by C1 plus C2. Here the common potential is equal to net charge divided by net capacitance, right? So now V equal to, so C1 is 2 microfarad, right? So 2 microfarad into V1 is 14 volt, right? Into 10 to the power minus 6 plus C2 is 5 microfarad, V2 is 0, whole divided by C1 plus C2, that is 5 plus 2, 7. Right? So now common potential V is equal to here it will be 0, right? So 7 2s are 14, 2 into 2 4, right? Isn't it? 2 into 2, 4. So here the common potential V is equal to 4, right? 4 into, so this is 2 microfarad, right? 14. So this will be microfarad. Okay, here microfarad is there. Okay, so micro here 10 to the power minus 6 will get cancelled, right? So this will be 4 volt. Okay, 4 volt. 4 volt. So the correct option is B. Understood? Yeah. Next question. Question number 5. The ratio of amplitude of magnetic field to the amplitude of electric field of an electromagnetic wave propagating in vacuum. So the ratio of the amplitude of the magnetic field to the amplitude of the electric field is reciprocal of speed of light in vacuum. So the correct option is A. Okay. E naught by B is C. So B naught by E naught is 1 by C. Next question. Question number 6. A particle is projected at an angle 30 degree with horizontal having kinetic energy K. The kinetic energy of the particle at highest point. Okay, so this is y axis and x axis, right? So particle is projected at an angle of 30 degree, right? So we need to find the kinetic energy at the highest point. So at the highest point, there is no vertical component of the velocity, right? Isn't it? So this is V, right? So this will be V cos 30 degree. There is no vertical component of this V, right? At the highest point, isn't it? So now here the velocity becomes velocity which is equal to V cos 30 degree, that is root 3V by 2, right? So now the kinetic energy K is equal to half m into V square, right? So this is the initial kinetic energy, right? So now new kinetic energy, that is kinetic energy at the highest point, K dash is equal to half into m into V square. V square is 3 divided by 4 times V square, right? So now half mv square is K, right? So now K dash is equal to 3 by 4 times K. So the correct option is B. Okay, yeah. Next question, question number 7. An air bubble in water, mu equal to 4 by 3, okay, that is the refractive index of the water, okay, is shown in the figure. The apparent depth of the image of the bubble in the plane mirror viewed by observer is, okay, we need to find apparent depth, right? So the dead easy question, right? And direct question. So we know that refractive index mu is equal to real depth divided by apparent depth, right? So they are asking you to find apparent depth. So apparent depth is equal to real depth divided by mu, that is refractive index of the water. So apparent depth is equal to real depth. Real depth is here 24 minus 8 centimeter. So that is 16 centimeter, right? 16 centimeter divided by mu is 4 by 3. So 4 4s are 16. 4 into 3 is 12. So apparent depth is equal to 12 centimeter. Yeah. Next question, question number 8. A TV tower has a height 72 meter. So h equal to 72 meter. The maximum distance up to which TV transmission can be received is, here the radius of the earth is 6.4 into 10 to the power 6 meter. Okay, so this one is also direct question, right? So we know the formula, the maximum distance up to which TV transmission is d equal to root of 2 h into r. So now d equal to root of 2 into h is 72 meter into r, that is 6.4 into 10 to the power 6. Okay, 6.4 into 10 to the power 6. So now d equal to, solve this, you will get 30.35 meter. Okay, 30.35 kilometer, not meter, kilometer. So the correct option is C. Next question, question number 9. A transistor is connected in collector emitter configuration. The collector supply is 10 volt and the voltage drop across the resistor of 1000 ohm in the collector circuit is 0.5 volt. If the current gain factor is 0.96, that is alpha, then the base current is, Okay, we need to find base current IB, right? Okay, so we know that current amplification factor beta is equal to IC by IB. So IB is equal to IC divided by beta. So we don't know the value of IC, we don't know the value of beta, but we can find from the given data, right? Okay, so let us find beta, that is current amplification factor. Current amplification factor beta is equal to alpha minus alpha 1 minus alpha, alpha minus 1 minus alpha, sorry, alpha divided by 1 minus alpha, 1 minus alpha, 1 minus alpha. Okay, this is beta, right? Current amplification factor. So alpha is current gain factor, right? So beta is equal to 0.96 divided by 1 minus alpha, right? That is 1 minus 0.96. 1 minus 0.96 is 0.04, right? So now beta is equal to, I can write it as 96 into 10 to the power minus 2 divided by 4 into 10 to the power minus 2. 10 to the power minus 2, 10 to the power minus 2 will get cancelled, right? So now here we can easily get the value of beta, right? So this will be 4 2s are 8, right? 4 4s are 16. So now the value of beta, that is current amplification factor, is 24, right? So let us find IC, right? That is current in, sorry, collector current, right? So collector current is equal to voltage drop across the collector, right? So that is 0.5 volt, right? 0.5 volt divided by resistance, right? Resistance in the collector, so or collector resistance. So now 0.5 divided by 1000 ohm, right? 1000 ohm. So now IC is equal to 0.5 divided by 1000 is 0.5 milliampere. Okay, collector current is 0.5 milliampere. Okay, we got the value of collector current. Let us find the base current. The base current IB is equal to collector current IC divided by beta. Okay, so now IB is equal to here 0.5 milliampere divided by beta, that is 24. 0.5 milliampere divided by beta, that is 24. So now solve this. Okay, you will get IB equal to 20.8 microampere. So the correct option is B. Okay, next question. Question number 10. One end of the string of length L is connected to a particle of mass m, and the other end is connected to a small peg on the smooth horizontal table. Okay, so this is the table. Okay, so this is the small peg and this is the particle. The string is connected between the peg and the particle. If the particle moves in a circle with speed v, okay, here the particle moves in a circle with speed v. The net force on the particle directed towards the center will be, T represents the tension in the string. Okay, so this particle moves with the constant speed v, right? So this particle experiences the centripetal force, right? So who is providing the centripetal force? The tension, right? Tension in the string. So tension in the string, T equal to m v square divided by L, right? So the net force acting on the particle is T, that is tension. Okay, so the correct option is A. Next question, question number 11. A thin circular ring of mass m and radius r rotates about an axis through its center and perpendicular to its plane. Okay, and the perpendicular to its plane with a constant angular velocity omega. Okay, so okay, I will draw here. So this is the ring. Mass of the ring is capital M. It is rotating with angular velocity omega. Mass of the ring is m. 4 small spheres, each of mass m, are kept gently to the opposite ends of the two mutually perpendicular diameters of the ring. Okay, so 4 particles here, here, here and here, kept diametrically opposite to the ring, opposite ends of the two mutual perpendicular diameters of the ring. So the new angular velocity of the ring will be, okay, because of these particles, angular velocity of the ring changes, right? Now it changes to omega dash. We need to find the value of omega dash. Okay, so here which concept we have to apply? Apply conservation of angular momentum, right? So why we are applying conservation of angular momentum? Because there is no external torque acting on our system, right? So what is our system? A ring plus 4 particles. Mass of the particle is small m. Okay, yeah. So apply conservation of angular momentum. What is the initial angular momentum? Initial angular momentum is I into, that is moment of inertia of the ring about its axis, into omega, equal to final angular momentum is moment of inertia of the ring, right? I plus moment of inertia of the 4 particles, that is 4 I dash into omega dash, right? So here I is mr square, right? Moment of inertia of the ring mr square, capital M into r square, into omega is equal to I is mr square plus 4 into small mr square into omega dash. Okay, so now omega dash is equal to here r square will get cancelled, omega dash equal to m divided by m plus 4m omega. So the correct option is here C. Okay, yeah. Next question, question number 12. The two wires of same material having radius in ratio 2:1, that is R1 divided by R2 is equal to 2 by 1, and lengths in the ratio 1:2, that is L1 divided by L2 is equal to 1 by 2. If the same force is applied on them, then the ratio of their change in length will be, okay, we need to find delta L1 by delta L2. This is the ratio of their change in length. Okay, so two wires of the same material, that is Young's modulus of those two wires is same, right? So we know that Young's modulus F equal to stress by Y equal to stress divided by strain. So what is stress? F by A. What is strain? Delta L divided by L. I mean longitudinal strain, change in length over original length. So now Y equal to FL divided by A into delta L. Okay, so now Y1 is equal to Y2, right? Y1 is equal to Y2. So Y1 is F1 into L1 divided by A into delta L1 is equal to F2 L2, here A1, okay, A2 into delta L2. F1 equal to F2 because the applied force is same, right? So F1, F2 will get cancelled. Okay, F1 equal to F2, right? Okay, so now here delta L1 divided by delta L2 is equal to delta L1 divided by delta L2 is equal to, so L1 divided by L2 into A2, okay, A2 divided by A1, right? L1 divided by L2 into A2 divided by A1. So let's check, delta L1 divided by delta L2 is equal to, take L2 to the other side, so L1 by L2 and A2 to the other side, right? A2 by A1, yeah, correct. So now delta L1 by delta L2 is equal to, here L1 by L2, right? L1 by L2 is 1 by 2, right? Into A2 by A1. Here A2 by A1 is pi R2 squared divided by pi R1 squared. So pi will get cancelled. So R2 by R1 whole square. So what is R2 by R1? 1 by 2, right? So R2 by R1 whole square is 1 by 4. So now the ratio delta L1 is to delta L2 is equal to 1:8. So the correct option is D. Okay, yeah. Next question, question number 13. In the figure, the pendulum bob on left side is pulled aside to a height h from its initial position. After it is released, it collides with the right pendulum bob at rest, which is the same mass. After the collision, the two bobs stick together and rise to a height. Okay, so here this is the bob, right? So this is the bob. On left side is pulled aside to a height h. Okay. Uh, Now after it released, it collides with the right pendulum bob at rest, right? So which is of the same mass. Mass of this pendulum is this bob is also same. Okay. After the collision, these two bobs, okay, stick together and raise some height h. We need to find that h. Okay, that height. Okay, so here the bob loses its potential energy, right? And it gains kinetic energy, right? So when it travels vertical distance h. So now loss in potential energy, that is mgh, is equal to gain in kinetic energy, that is half m into v square. Okay. So here m will get cancelled. V equal to root of 2gh. V equal to root of 2gh. So this is the velocity of the bob when it is about to hit the when the bob is about to hit the other bob, right? Okay. So after the collision, what happens? Both bob will stick together and moves some height h, right? Okay. So now here what happens? It loses potential energy and gains kinetic energy, right? Sorry, it loses kinetic energy and gains potential energy, isn't it? So now what is the kinetic energy, right? So now the kinetic energy, right? Okay, before that we need to apply conservation of momentum theorem. So what is the conservation of momentum theorem? Initial momentum is equal to final momentum, right? So what is the initial momentum? Initial momentum is mass of this bob into velocity of the bob, m into u, is equal to, after the collision, what happens? Both will stick together and moves, right? So the total mass will be 2m into v dash. Here m will get cancelled. Sorry, this is v. Okay, so this is v. So now v dash is equal to v divided by 2. So after the collision, it moves with velocity v dash, right? Okay. So now apply the conservation of energy theorem, right? So it loses kinetic energy and gains potential energy, right? So loss in kinetic energy equal to gain in potential energy. So now what is the loss in kinetic energy? Half 2m into v dash squared, right, is equal to gain in potential energy is 2m into g into h dash. Here 2m will get cancelled. V dash is v square by 4. V dash is v by 2. That is v dash square will be v square by 4 equal to g into h dash, right? G into h dash. Okay. So now what is v square? V square is 2gh, right? So half into 2gh divided by 4 equal to g into h dash. So g will get cancelled. Here 2 will get cancelled. So h dash is equal to h divided by 4. So the correct option is D. Okay, yeah. Next question, question number 14. A gas is taken through the cycle A, B, C, A as shown in the figure. What is the net work done by the gas? Okay, net work done by the gas in PV graph is equal to the area under this curve, right? Or area of this triangle, isn't it? So what is the area of the triangle? That is work done. Work done is equal to half into base. Base is 7 minus 2, that is 5. 5 into 10 to the power minus 3 meter cube into height. Height is 6 minus 2, that is 4. 4 into 10 to the power 5 Pascal. So work done is equal to, here this will be 2, right? And then 10 then 10 to the power 2, so 1000 joule. So the correct option is B. Okay, yeah. Next question, question number 15. The gases carbon monoxide and nitrogen at the same temperature have the kinetic energies E1 and E2 respectively then. Okay, what is the kinetic energy expression? Half kb into T, right? So kinetic energy expression is half kb into T, right? Isn't it? Sorry, 3 by 2 kb into T, not half kb into T, 3 by 2 kb into T, right? Or average kinetic energy expression or kinetic energy expression. So now it does not depend on the mass or molar mass of the given gases, right? So energy of the carbon monoxide is equal to energy of the nitrogen. So the correct option is A. Okay. Question number 16. Two wires are made of the same material and have the same volume. Okay, both have the same volume and made up of the same material. So Young's modulus of those two wires is same. What is the Young's modulus formula? F into L divided by delta L into A. The first wire has cross-sectional area A, that is A1 equal to A, and the second wire has cross-sectional area 3A, A2 equal to 3A. If the length of the first wire is increased by delta L on applying force F, okay, so here delta L1 equal to delta L. How much force is needed to stretch the second wire by the same amount? Okay, so here we need to find how much force needed to stretch the second wire by the same amount, that is delta L only. Okay, delta L2 is also equal to delta L. So Young's modulus of the both wire is same, right? Y1 equal to Y2. So now here, okay, remember in previous problem what we have found here, in there we have found here this problem, right? We have found the ratio of the change in length, right? So here we are finding, look here we are finding the force, right? In that case force was same, isn't it? So in this case the change in length is same, right? So same question, right? Isn't it? I mean similar question, isn't it? So y1 equal to here f1 into L1, okay, f1 into L1 divided by A1 into delta L1, which is equal to f2 into L2 divided by A2 into delta L2. So now here multiplying divided by L1, here multiplying divided by L2. So now this becomes, sorry, here multiplying divided by A1, okay, here multiplying divided by A2. So now f1 into here f1 into volume, right, volume divided by A1 squared into delta L1, so V1, okay, which is equal to f2 into V2 divided by A2 into delta L2, A2 squared into delta L2, right? So both have the same volume, right? V1 equal to V2, so V1 equal to V2, right? Okay, so we need to find F2, right? So F2 is equal to okay, again delta 1 equal to delta L1 equal to delta L2, right? Delta L1 is equal to delta L2. So F2 is equal to here F1 into A2 squared divided by A1 squared into F1. So now F2 is equal to A2 squared, right? A2 squared is 9A square divided by A1 square, that is A square into F1. So now A square will get cancelled. F2 equal to 9 times F1, that is 9 times F. So the correct option is C. Okay, yeah. Next question, question number 17. Starting from the center of the earth having radius r, the variation of g, acceleration due to gravity, is shown by. Okay, starting from the center of the earth having radius r, the variation of the g is shown, right? Okay, here we know that acceleration due to gravity uh, below the surface of the earth, right, that is g dash is equal to g is acceleration due to gravity on the surface of the earth into 1 minus d divided by r, right, 1 minus d by r. So now g dash is equal to g into r minus d by r minus d by r. So now g dash is equal to g into r divided by r. Okay, so what is r? Capital R minus d. R is radius of the earth. Okay, d is depth below the surface of the earth. So from this I can conclude that g dash is directly proportional to r, right? So if I draw variation of acceleration due to gravity and r, so from the center of the earth to the surface of the earth, acceleration due to gravity increases linearly, right? On the surface of the earth, acceleration due to gravity is g. Sorry, r equal to r. Okay. Yeah. So this is r. So now, when you move away from the surface of the earth, that is acceleration due to gravity at height h above the surface of the earth, right? So now acceleration due to gravity g dash is equal to g into r square divided by r plus h whole square, right? So g dash is equal to g r square divided by small r square. What is small r? R plus h. Okay. So now acceleration due to gravity decreases inversely, square of the inverse, right? So it will be like this. So 1 divided by r square. So the correct option will be B. Okay. Yeah. Next question, question number 18. A long spring, when stretched by a distance x, has the potential energy U. Okay, U equal to half kx square, right? On increasing the stretching to nx, that is x dash equal to nx, the potential energy of the spring will be, okay, now new potential energy is equal to half k into x dash squared. So now U dash is equal to half k into n square x square. So half k x square is U. So U dash is equal to n square U. So now new potential energy is n square U. So the correct option is C. Next question, question number 19. With what velocity should an observer approach the stationary sound source so that apparent frequency of the sound should appear double the actual frequency? Okay, here this is the source, right? And observer is moving towards source, right? So now apparent frequency heard by the observer, f is equal to f dash is equal to f into v minus vo divided by v. So what is v? Velocity of the sound in air. Vo is velocity of the observer. Okay. So now f dash is equal to 2f. Okay. F dash is equal to 2f, which is equal to f into v minus vo divided by v. So now f will get cancelled. 2v equal to v minus vo. Okay, 2v equal to v minus vo. So vo equal to minus v. So what is the meaning of negative sign? The meaning of negative sign is observer moving opposite to the direction of the velocity of the sound, right? So the correct option is D. Okay, yeah. Question number 20. Dielectric of dielectric constant K is introduced such that half of its area of a capacitor of capacitance C is occupied by it. The new capacity will be, okay. So let us draw the diagram. Okay. So this is the parallel plate capacitor. Okay. So here we have filled this parallel plate capacitor, okay, by the dielectric and not completely filled, okay. It covers half of the area. It covers half of its area, right? Yeah. Okay. So what is the dielectric constant of this dielectric? It's K, right? So now area is A by 2 and A by 2. Distance between the capacitor is same, okay? Two parallel plate is same, that is D. Understood? Yeah. So we need to find new capacitance, right? So now if I draw in 2D, so this is how does it looks like, right? So this is K, right? Isn't it? So here K equal to 1. This is D. So now these two are in parallel, right? These two are in parallel. So C dash, that is capacitance of the capacitor when the dielectric is filled. C dash is equal to A epsilon naught K divided by D, right? So now here, so now I can write C dash as C into K, right? C into K. Okay, so now here half is filled, right? So C dash is equal to, here area is A by 2, right? A by 2 into epsilon naught K divided by D. So A epsilon naught divided by D is C, right? So C dash is equal to C into K divided by 2. Okay, C into K divided by 2. So now what is the capacitance of the this capacitor, right? This one, K equal to 1, right? So C double dash is equal to A by 2 into epsilon naught epsilon naught divided by D. Okay, K equal to 1, right? Epsilon naught by D. So A epsilon naught by D is C, right? So C double dash is equal to C by 2. So now these two are in parallel, right? So now C equivalent is equal to C dash plus C double dash. C equivalent is equal to C dash, that is C K by 2 plus C double dash is C by 2. So now C equivalent is equal to, take C as common, okay, sorry, C by 2 as common, take C by 2 as common, so then the remaining will be K plus 1. So the correct option is C, okay, correct option is C. Next one, question number 21. Two very long straight parallel wire carry currents I and 2I in opposite direction, okay, I and 2I carries, so these two are the current and the direction of the currents are opposite. The distance between the wires is R, okay, distance between them is R. At a certain instant of time, a point charge Q is at a point equidistant from the two wires in the plane of the wire, okay. So this is the point P, okay. So this is equidistant from these two wires, that is R by 2 and R by 2. Here the charge is placed, charge Q is placed, right? Its instantaneous velocity is V, perpendicular to the this plane, okay. The velocity, instantaneous velocity of this charge is V, okay, perpendicular to the plane, either it is outward or inward, okay. So you can consider anyway, so either it is outward or inward, okay. I am considering outward, okay. This is the instantaneous velocity V, perpendicular to the plane, okay. The magnitude of the force due to the magnetic field acting on the charge at this instant, okay. We need to find magnitude of the force on this charge, okay, on this charge due to magnetic field acting on this instant. So what is the direction of the magnetic field? Okay, what is the magnetic field at point P due to these two wires, right? So the direction of the magnetic field at point P due to the first wire, that is the current carrying, the wire carrying current I, is into the plane, right? Again, the direction of the magnetic field at point P due to the second wire, also into the plane, right? But the velocity is outward from the plane, right? So we can say, okay, velocity is outward from the plane, right? So the velocity and magnetic field both are in opposite direction. The force acting on the charge is Q into V into B sin theta. Q into V cross B, so Q into V into B sin theta. So theta is angle between V and B, that is 180 degree. Sin 180 degree is 0. So the force acting on the charge is 0. So the correct option is A. Okay, yeah, theta is 0 degree. Next question, question number 22. The magnetic flux linked with the coil satisfies the relation phi equal to 40 square plus 60 plus 9 Weber. What T is the time in second the EMF induced in the coil at T equal to 2 seconds is? Okay, so here we need to find induced EMF in the coil at T equal to 2 seconds. The direct question, right? Induced EMF in the coil E equal to rate of change of magnetic flux, right? d phi by dt, magnitude of rate of change of magnetic flux. So now E equal to, so what is the rate of change of magnetic flux? 40 square plus differentiation of 40 square plus 60 plus 9 with respect to T, right? What is the differentiation of 40 square? 4 into T square, that is 8T, right? 8T plus what is the differentiation of 66 plus 0. Here T equal to, at T equal to how much? 2 seconds, right? Now substitute the value of T, right? So T is 2, 8 into 2 is 16 plus 6, 22 volt. So the correct option is A. Next question, question number 23. The instantaneous values of the alternating current and voltage in a given circuit, in a circuit given as I equal to 1 by root 2 sine of 100 pi t ampere, E equal to 1 by root 2 sine of 100 pi t plus pi by 3 volt. The average power consumed in the circuit is, okay, consumed in the circuit is. So now here the average power is equal to IRMS into ERMS cos phi. What is phi? Phase difference, right? So what is the phase difference? Pi by 3. So let us find IRMS and ERMS. So what is IRMS? IRMS is equal to I naught divided by root 2. So what is I naught? I naught is 1 by root 2, right? So 1 divided by root 2 ampere, right? So IRMS is equal to 1 by root 2 into 1 by root 2, that is 1 by 2 ampere. So now ERMS is equal to E naught divided by root 2. So what is E naught? E naught is 1 by root 2. 1 by root 2 into 1 by root 2, 1 by 2. So ERMS is equal to 1 by 2 volt. Okay. So now phi equal to pi by 3, right? Phi equal to pi by 3. Substitute all the values. P average is equal to IRMS, that is 1 by 2 into ERMS 1 by 2 into cos phi. Cos phi is cos 6 pi by 3, that is 1 by 2. So P average is equal to 1 by 8 watt. So the correct option is D. Okay, yeah. Next question, question number 24. A car is moving towards a high cliff. The car driver sounds a horn of frequency F. Okay, so this is the high cliff. Okay, so this is the car. Velocity of the sound is, velocity of the source is Vs, right? That is also velocity of the sound, and velocity of the observer is Vo. Both are moving, right? So frequency of the wave is F, or sound is F. The reflected sound heard by the driver has a frequency 2F. Okay, so now this is the reflected sound. So now the frequency heard by the observer is 2F when the wave got reflected. If V be the velocity of the sound, then the velocity of the car in the same velocity units will be. Okay, so here apparent frequency heard by the observer F dash is equal to F into here observer and source both are moving towards the cliff, right? Both are moving in the same direction. So this will be V plus VO divided by V minus VO. Sorry, V minus Vs. Okay, so Vs is velocity of the source, VO is velocity of the observer. Okay, So now here velocity of the sound is v, right? Velocity of the sound is v. So now f dash is 2f. So 2f is equal to f into v plus vo divided by v minus vs. Vs is also vo, right? Vs is also vo. So now f will get cancelled, right? So now v minus vo into 2 is equal to v plus vo, right? So now 2v minus 2vo is equal to v plus vo. So now v is equal to 3vo. So vo equal to v divided by 3. So the correct option is B. Okay. Yeah. Next one. Question number 25. If escape velocity on the Earth's surface is 11.1 km per hour, then find the escape velocity on Moon surface. If the mass of the Moon is 1 by 81 times mass of the Earth, that is m of Moon is equal to 1 by mass of the Earth divided by 81 times. Okay. And radius of the Moon is 1 by 4 times radius of the Earth. Radius of the Moon is equal to 1 by 4 times radius of the Earth. Okay. So we need to find escape velocity on the Moon. So now here escape velocity, the expression of escape velocity is v equal to root of 2 on the surface of the Earth, okay, root of 2 gme divided by re, right? Root of 2 gme divided by re. So escape velocity on the Moon will be root of 2 gmm divided by rm. Okay, we need to find escape velocity on the Moon, right? Isn't it? So escape velocity on the Moon divided by escape velocity on the Earth is equal to root of anyway 2g will get cancelled, mass of the Moon divided by radius of the Moon whole divided by mass of the Earth divided by radius of the Earth. So now Vm is equal to mass of the Moon is 1 by 81 times mass of the Earth, right? So mass of the Earth and radius of the Earth here both will get cancelled. So 1 by 81 into Rm is 1 by 4, right? Re by 4, Re will get cancelled, so this will be 4. So Vm is equal to 2 divided by 9 times Ve. Okay, so V is 11.1 km per hour. So Vm is equal to 2 into 11.1 km per hour divided by 9. So finally Vm is equal to 2.46 km per hour. 2.46 km per hour. So the correct option is A. Okay. Understood? Yeah. Next question, question number 26. An ideal gas goes from state A to state B. Okay, state A to state B via 3 different processes as indicated in the PV diagram. If Q1, Q2 and Q3 indicate the heat absorbed by the 3 processes, and delta U1, delta U2 and delta U3 indicate the change in internal energy along the 3 processes respectively, then. Okay, so here in PV graph, okay, so when internal energy does not depend on the path. Okay, internal energy does not depend on the path. So delta U1 is equal to delta U2 is equal to delta U3. There will be no change in internal energy. Okay, so let us find the heat. Okay, Q1, Q2 and Q3. So here the work done in PV graph is area under the curve, right? Isn't it? So W1 is greater than W2 is greater than W3, isn't it? W3. So from this I can conclude that Q1 is greater than Q2 is greater than Q3. Okay, so we know that Q is equal to U plus delta U, delta W, right? Or delta U plus delta W. So from that equation we can easily conclude that Q1 is greater than Q2 is greater than Q3. Okay, so the correct option is A. Next question, Question number 27. In the series LCR circuit shown, the impedance is, okay, so in series LCR circuit, impedance is Z equal to R square plus XL minus XC whole square. Okay, so Z equal to root of R square is 300 squared plus XL, that is omega is 2 pi F, right? So 2 pi into F, that is 50 by pi, into L is 1 minus XC, that is 1 divided by omega is here 50 by pi into 2 pi, so 2 pi into 50 divided by pi into C is 20 microfarad, 20 into 10 to the power minus 6. Okay, so now Z is equal to solve this, okay, you will get 500 ohm. So the correct option is D. Next question number 28. In Young's double slit interference experiment using two coherent waves of different amplitudes, amplitudes are A1 and A2. Okay, the intensities ratio between the bright and dark fringes, that is maximum I max and I minimum, okay, I minimum is 3. Okay, the ratio I max, ratio of the bright and dark fringe, right? I max by I minimum is 3. Then the value of the ratio of the amplitudes of the waves that arrive there is, that is A1 divided by A2 is, what is the ratio? A1 by A2, right? Okay, so we know that I max by I minimum is equal to A1 plus A2 whole squared divided by A1 minus A2 whole square, right? Isn't it? So here, why it is A1 plus A2 whole square by A1 minus A2 whole square? Because intensity is directly proportional to square of the amplitude, right? So now I max by I minimum is equal to A1 plus A2, right? So I can rewrite this equation as here this is 3, which is equal to A1 divided by A2 plus 1 divided by A1 divided by A2 minus 1. Take square root on both sides, so this will be root 3, right? Okay, so now here A1 divided by A2 plus 1 is equal to root 3 into A1 divided by A2 minus 1. Okay, into root 3. 1 into root 3 is root 3. So now A1 divided by A2, take A1 divided by A2 as common. So here A1 by A2 taken to the other side, right? So this will be root 3 minus 1, okay, equal to here root 3 plus 1. So now A1 divided by A2 is equal to root 3 plus 1 divided by root 3 minus 1. So the correct option is A. Okay, yeah. Next question number 29. The wavelength of the first line of Lyman series for hydrogen atom is equal to that of the second line of Balmer series for a H-like ion. The atomic number Z of the H-like ion is, okay. So we know that when electron makes transition from higher energy level to lower energy level, what happens? The photon will emit, right? So we know that 1 by lambda is equal to, in hydrogen atom, okay, 1 by lambda is equal to R into 1 divided by Nf square minus 1 divided by Ni squared. Okay, so now 1 divided by lambda equal to R into 1f square, 1 by Nf square minus 1 by Ni square, right? So now multiply both side Hc, right? So now Hc by lambda is equal to R into Hc into 1 divided by Nf square minus 1 divided by Ni square. So what is Nf? Final energy state, okay, and Ni is initial energy state. Understood? Yeah. So now this is for hydrogen atom. For hydrogen like atom, hc by lambda is equal to z square into r into hc into 1 divided by nf square minus 1 divided by ni square. Okay. Here the wavelength of the first line of Lyman series for hydrogen atom is equal to that of second line of Balmer series for hydrogen like atom. So in first line, okay, wavelength of the first line of Lyman series, that is electron makes transition from n equal to 2 to n equal to 1, right? In Lyman series, n equal to 2 to n equal to 1, right? N equal to 2 to n equal to 1. So this is NF, this is Ni. In Balmer series, the second line of the Balmer series, right? In second line of the Balmer series, electron makes transition from n equal to 4 to n equal to 2, right? So here this will be Ni and Nf, isn't it? So here these two are equal, right? We need to find Z, atomic number. So now RHC, anyway RHC will get cancelled, right? So 1 divided by, so this is for Lyman series, 1 divided by NF square, that is 1, minus 1 divided by Ni square, that is 4, is equal to Z square into 1 divided by NF square, that is 1 by 4, minus 1 divided by Ni square, that is 1 by 16. Okay. So now this is 3 by 4, which is equal to Z square into, take 1 by 4 as common. So now 1 minus 1 by 4 is 3 by 4. So 3 by 4 into 1 by 4 is 3 by 16. So now 4 4s are 16, right? So 3 will get cancelled. So the value of Z equal to 2. So the correct option is C. Okay. Yeah. Next one, question number 30. If 150 joule of heat is added to a system and the work done by the system is 110 joule, then the change in internal energy will be. Okay, we need to find change in internal energy, right? So we know that here the change in internal energy delta U is equal to here Q minus work done, okay, W. So now delta U is equal to Q is 150 joule minus work done is 110 joule. So now delta U equal to 40 joule. So the correct option is A. Okay. Yeah, done. Right. Okay, thank you. Thank you so much for watching this video. So if you love this video, please like and share. And if you want to watch more such videos, please subscribe. Thank you.